part is about implementing offline mode. So it kind of ties into what we talked about previously, the suspension manager, because this time we will also have to save our data to an object store somehow. Actually, there's quite a lot to implementing an offline mode, more than you would expect at first, because, well, actually, you have to start working with cached or stored data. So the first thing we will have to do is we will have to look into how we can do that. So what are our options for saving data? And how can we serialize our data to the necessary object store? Then we, of course, need to make sure that we save data at the appropriate time and or read data back at the appropriate time. And to be able to do that, we need to be able to detect whether or not we're offline in this case. Because typically, what we're going to do here, at least, is we're going to save our data when we fetch it live. And if we happen to be offline when we start the application, or if we happen to go offline at some point, we need to work with what we've saved in the object store. And we cannot access our services live. So that's a few things we have to do, but we also have to keep in mind that the connection can suddenly fail. Now, of course, that's one of the errors that can happen. So we're writing an application in which let's imagine we're writing an application in which we're doing quite a lot of stuff with the data we get back. Exceptions might happen. We need some way to handle them. Typically, of course, you write exception, try catch around your code. But there's a few things you have to keep in mind here, especially when you're writing or trying to handle exceptions that come from methods that are awaitable. There's a bit of a gotcha there. So what I typically like to do is write an error handling service that I will use to handle my errors everywhere, and the specific implementation of how to handle a specific exception. Typically, this is logging the exception, in my case, will be in the error handling service. So these three things are what we have to make in this session. So first thing, caching and storing data or the object store. How can we do this and what are our options? Well, interesting to know is we have roaming data, local data, and temporary data. Roaming data, the data you save here in a roaming folder, that one is automatically saved in the cloud. So the general idea is that when you have a Windows machine and you're a Windows 8 user, you are not actually tied to one machine. You are tied to your user account, your Microsoft account typically in this case, and your Microsoft account in turn is connected to the cloud through SkyDrive typically. You can actually use roaming data in your applications, and this data that belongs to that application will automatically be synced online and synced down to your application even if you open it on another machine. So that's quite interesting to know that something like that exists. I do advise you to keep those amounts a bit minimal. So don't start throwing hundreds of megabytes, that won't work by the way, throwing hundreds of megabytes online. There are some options for this. This part of what we're talking about is effectively saving larger amounts of data. There's also something like application settings. I talked about this before a bit. Application settings can also be stored in roaming folders, which is typically good practice. But also there you have to keep them very, very small. Specifically if you want them to be immediately in the cloud. It can take a bit of time. But the thing to remember about this is that as far as coding this stuff is concerned, you don't have to do anything to get this. You actually get this for free. You just specify in what type of folder, what type of application folder in this case you want to save your data. And then you can state I want to save it in a roaming folder or the local folder tied to this machine, to this application on this machine to be more specific, or a temporary folder, which means that once your app is terminated, that temporary folder is also made empty again. as most stuff in Windows 8, also loading and saving, loading data from, saving data to your object store is async. So you have to keep that in mind. Typically you would use an iRandom access stream for this. I will immediately show you an implementation because I have found stuff like this is something you do in a lot of applications and throughout your application even. So what I typically do is I write a helper class for this. So just have a helper class that contains the save methods, the load methods, and I can use that throughout the application. So that's the first thing I'm going to show you. It's only part of the demo, so it won't actually run yet, but I'm going to show you the implementation already of such an object storage helper. So this is actually an object storage helper. And with this I can show you how you can write data to your object store or save it from, or load it from the object store. So it's actually a generic class, and I'm immediately going to go to the save method. I tend to like working with JSON data. A lot of applications get their data from the net. A lot of REST-based services typically return JSON rather than XML. So I'm quite a big fan of Newtonsoft's JSON.NET, and I tend to use that all over. So this is something I use a lot instead of the suspension manager, which works with XML. This allows me a bit more control. So what I do is just instantiate my object storage helper, passing in the type T, and the save async method. As you can see, it's an awaitable method, and as you can see here immediately, these are built-in methods that are async, just as most stuff in Windows 8. So I first serialize my result to a JSON string. Tend to like to work with readable data. You can binary save as well, by the way, but just for information. I ask for the type of folder I want. Depending on the storage type, I instantiated my object storage helper with. Typically for most applications I use local data, but as said, you can use roaming data if you want your user to be able to access specific types of data on any machine. I typically use roaming data for my application settings, and not so much for stuff I save on the machine. Although you can imagine an application in which you are editing a document and you automatically want to be able to keep on editing that on another machine, then you could use stuff like the roaming folder. It all depends on, again, your application. So this is built in. So my get folder method, let's quickly look at that one, actually simply returns a storage folder. It's as simple as that. And in that folder, let's have a look at that. You can see that there are a bunch of methods implemented on storage folders. So you can create files, you can create folders, you can create items. And of course you can get all that stuff. So there's quite a lot of stuff in there, which is probably familiar to most of you as you've probably worked with file I/O. With this one big change is that everything is now async. That is quite important. So even creating a file here, that's an async method, so I have to await that. And then I open a file. I need a write stream, which in this case is an iRandom access stream. There are other types of streams included, of course, in WinRT. This is one that's used most often, actually. So what you can do then is use the data writer. That's another one that's automatically that's included. And the rest of what is here is probably very familiar. You actually just write the data away, you flush your stream, and of course you close the necessary streams. That's the save method. The load method again, same logic. You get the folder, I try to get the file, and then I read from the file. The one thing I have to add here is that I also need to serialize back using JSON.NET in this case, because I've saved using JSON.NET. Now I need to deserialize my object using JSON.NET in this case. And of course, you end up returning the object you've loaded. So that's all I wanted to show about the helper method. In a few minutes, I'm going to show you where I use it, but we'll need a few more slides before that. So let's see. Back here. Okay, so next, how do you actually detect whether or not you're offline? Well, there's actually a pretty nice built-in class for that. Windows networking connectivity network information contains a network status changed event. So by handling that event, and this event is actually triggered every time your user goes online or offline, or actually changes the type of connection he has from Wi-Fi to 3G, etc. Then this network status changed event is triggered. So if you handle that somewhere in your app, a typical place would be app.xaml, .cs. If you handle that, you can continue your application with code according to the network status or network connection you have. So this goes a bit further than only detecting offline mode. You could say, well, if I'm on Wi-Fi, I am automatically going to load the high quality pictures for my app. And if I'm on 3G or even GPRS, I typically do not want to load the very high quality pictures from my web service. I only want to load the very low quality pictures because these people are on a network connection that doesn't really allow for much data transfer. So that's how we check whether or not we're offline and how we check when the mode has changed. Now, the next thing we have to do, we now know how we can save and load data to our object store, to the different types of folders. We know how we can detect offline mode. Now we somehow need to check this mode and get our data accordingly. So what I tend to do is in most applications, I have a state container or data store class, something like that. What I did in this demo, which I'm immediately going to show you, is that once the app is loaded, I'm going to no longer get the data from the service in my view models, but I'm using my data store to call my service and get my data. And in that data store, I check whether or not I'm offline. So I load my application into data store, will know whether I'm offline or not, and will load the data either from the live service or from the stuff I've already saved in my object store. So that's one way of doing this. For bigger applications, you would typically want to go a bit further. In this demo, I have, well, we actually have a bunch of categories with products in it, and that's about it. If you have a bigger application, you would typically want more fine-grained control. For that, you can again use load state and save state on your views. So then we have that. After the data has been loaded, of course, the view models are notified through the message sending, and they get their data then from the object store instead of loading them themselves. Now, what if something goes wrong? Well, then we have to handle our exceptions. So what I like to do is I create an exception handler service and use that to handle unexpected exceptions, by the way. Some exceptions are expected. Whether or not there are exceptions, it's up for discussion, but it tends to happen in some applications. Now, typically, how do you handle these exceptions for service calls? It's quite easy. You can actually use the try-catch blocks around a WCF service call in this case. But there's a bit of a catch for async or awaitable methods. More specifically, sometimes awaitable methods aren't awaited, and if an exception happens in such a method, you actually lose it. But there is a way to handle those, and I am also going to show you. So what I'm going to do in this demo, I'm going to tie all these previous slides together and get our application to work with online or offline data and make sure it handles the exceptions accordingly. So let's try that. All right, I'm back in my application. So first thing I'm going to show you is how to check for offline and online mode. As I said, app.xaml is quite a good place to do this. Let's see. First thing I do when the application launches, I'm going to check whether or not I'm online or offline. So I use network information, get internet connection profile, .get network connectivity level. So this actually goes a bit further than just yes or no, I'm online or offline. So I have a simple switch statement here. We'll check if I got constrained internet access. Do I have internet access, only local access, or am I not connected at all? And depending on this, I set a value in my state container, which is a simple class, static class, containing a few values I use throughout my app. I set a value there to check whether or not I'm online. This is actually the value that will be used to know whether or not I have to get my data from the live service instead of from an existing, from the data store. Now, why do I do it like this? This is a bit less less costly than always rechecking your network state every time you need to get data. Now, of course, where did I put it? Register for network status changed. That's the other one. So, when the network status changes, which is this event, I execute that same method again. So this allows me to ensure that when my application starts, I know what mode I'm in, and it's only when this mode actually changes that I change it again in my state container. So I never manually recheck on each call. I just rely on the network status changed event to be fired and then load my data accordingly, or know where I have to load my data from accordingly. So with that done, I now have to load my categories. Now, instead of doing that in the view model, I now use a data store, quotation marks, for this, which in my case is my state container. So there's actually a pretty simple method in here, load categories, which will check whether or not I'm offline. This is set on app startup. If I am offline, I use the object storage helper I just shown you to load an observable collection of catalog category from my local folder. And I actually save that in a property on my data store, which in this case is my state container. So this will now be my observable collection of categories. If I am not offline, I of course do this live and save them afterwards to the object store. After the data has been loaded, I tell my view model, which in this case would be the products group view model. And this one, receives a message, refresh data, refresh category data message. Tell it that it should refresh the data, which actually just fills the property my view is bound to the state containers categories ordered by short title, which is the same as what we had in the first exercise. Okay, so what have we got now? We've got an application that will load my data from local or live services. Now, to test this, first going to run it normally. So in this case, whether or not I'm online or offline, it's actually two things I need to be able to check here. Oh, I don't need these breakpoints anymore. First one, online or offline, whether or not my machine is online or offline. But in this case, my services are actually on my local host. Wouldn't really matter. So I kind of need to fake it. So let's see what we can do. First run, I am online in this case. So this actually means my data has now been saved to my object store. And the second time around, now I want to show that it can actually be loaded from the object store and still works. So I'm now going to fake being offline by simply returning, let's see, maybe I can just, maybe if I disconnect, that should work. So we are now assuming my services are actually online somewhere. Let's see. I'm disconnected from the internet, so okay. Back in the app, set online offline mode. Let's check. That's obviously not a good idea. Right, I think I need a try catch around this. This was actually my demo code. Now it should have returned offline. I think something's going wrong here. Right. That might have been it. Okay, am I offline? Yeah. So let's see if I have got stuff correctly saved in my object store. Let's put a breakpoint. Here. There we go. And I loaded it. And I actually have data in my categories. I sent refresh category data message to my view model. It should be done now. And as we can see, here's my data. Not variable sized anymore. That's the next exercise. So here's my data back from a call to my local store instead of to the service. Okay, now, what about exceptions? Of course, the simple way of exception handling, that's what you can do and what you could do earlier. Just using a try catch around the call to get categories. Now let's see. I have to ensure this call actually succeeds. So, first thing I need to do, this is why this was on false, by the way, second demo. First thing I need to do, I need to ensure my application thinks it's online. So I return is offline false by default. And then I want it to actually fail. I want the call to fail because I want to see my exception is handled accordingly. So once the call fails, I ask for an instance of an exception handler service, which is something I typically like to use, which gets the exception passed in, and then I handle it accordingly. This typically depends on the type of exception you get, etc., etc. These are also typically exceptions that come from your service calls, not locally. What you would, at minimum, want to do here, well, sometimes you might want to log it, sometimes you might want to show it in a message dialog, sometimes you might want to do other things depending on how your application is built. In this case, I'm showing it through a message dialog. So the one thing that's left to do now is to ensure I get this exception. So I faked the fact that I'm online by default. But this call is still going to work, of course, because I'm working locally. So I'm now going to take my service hosts. Let's see if I can put that on another URI. Yeah, that's the point. There we go. Now, of course, this call should fail because I am still calling the previous URL. So let's see if it actually does fail. Okay. So I should be, that worked. Now knows I'm offline, I'm online, and now this should fail. And there we go. I actually get an exception. Could not accept the message, of course not. I'm trying to call a different place. And here we go. I have this exception handler service that now does not much more than show my exception. By the way, you should never show these exceptions to your users, of course. That's a way to handle exceptions on your services, on your service calls at least. But there was one other thing I talked about, which is exceptions that happen in awaitable methods. And that's a bit special actually. I'm going to show you this. I've actually created an awaitable method that throws an exception. I'm going to see when I call it. First, I'm going to quickly get this back to normal. There we go. So this is just a method, and I just throw an exception in this. Now, if you await this method, this exception will be thrown, and you will actually, it will bubble up to here. And if you don't handle it here, it will bubble up even further, just right up to unhandled exception in your app.xaml.cs. Unhandled exception is one of those places where a lot of people tend to catch exceptions they somehow forgot. Of course, you should never forget to catch exceptions, but as we all know, sooner or later we will forget to catch an exception somewhere. So that's why unhandled exception in app.xaml.cs is often used for this, to ensure your user doesn't crash out of your application, or at the very least to be able to log that exception, which is probably more important. I'm guessing if you have an unhandled exception somewhere, something unexpected happened and probably your application state isn't exactly what it should be anymore. So app unhandled exception is something I would always handle, but I will typically use it to somehow log the exception, get it back to via a service call through your server, or log it locally and upload it the next time you need, the next time the user opens the application, whatever way you choose. But I think it's important to be able to catch every exception that happens, because it's an unexpected thing in your application. And here's the problem. First, going to show you how it works. So this should work. I'm going to put another one here. There we go. There we go. Only thing I do is throw an exception, and it actually throws the exception. That's good. When doesn't this work anymore? When you don't await that method. And that's actually not as weird as it may sound. Not waiting for an awaitable method actually happens quite a lot when developing. Typically, imagine the case where you have an awaitable method that executes, that in some places has to execute some kind of algorithms on your data that you need for execution to continue on that page, but in other cases might just be called to start running some logic already, but you don't necessarily want it back on that page. You just want it to run in the background, and you don't want to handle it after it's been finished. It actually happens quite a lot, and now this happens. So we're running again. Okay, what's going to happen now is your exception will be thrown, but I will go nicely to this breakpoint afterwards. I won't go back. I'm already handling this exception in another way, so there actually is a way to get that one, and that is through the task scheduler dot unobserved task exception event. Why is this? Well, this is actually parallel task framework in the background. So async await, that's actually just tasks in the background. So using the task scheduler, you can actually get to these exceptions. So let's see if this is actually true what I'm telling. So I push F5 now. My method isn't awaited, but it somehow will throw an exception. I am at the end of this method. Somehow that exception has happened. I wasn't notified of it, but thanks to the fact that I am handling the unobserved task exception, I do get that exception. So here it actually is. Of course, you kind of need the inner exception after a while. Now the thing is, if you do not handle this, the exception will be thrown by your code, but you will never know about it. So I think that's a pretty important thing to know.